Hello and welcome to CSCI 41. My name is Lawton Nichols, and you cannot see me right now, so let me show you my face at least once. I will open up my webcam really quickly so you can see my face. Let's start a meeting. Sure. Just in case you never come to office hours, you'll have seen my face. Hello. I need a better green screen, I guess. My background's not good enough. But this is me. It's nice to meet you. And there I go. Back to the PowerPoint. So yeah, welcome. Let's get started. So first I'll talk about me, then we'll talk about the syllabus, and we'll get into some real coding. I also have a review if you want to watch that. So just briefly about me. So hi, my name is Lawton. I use he and him pronouns, and if you would like to, it might feel weird, but I would prefer it if you called me by my first name. Call me Lawton. Other things that I will respond to: Mr. Nichols, Dr. Nichols, Professor, or insert your favorite name here. Doesn't really matter. I'll respond to everything. But if you feel like it and it doesn't bother you, please call me by my first name. I want to earn your respect. I don't want to have it at the beginning. So there's that. Yeah, so I went to Fresno State for my undergrad. So I know a little bit about the place if you're trying to transfer there. And I just got done with UC Santa Barbara. That's where I went for grad school, and I majored in computer science everywhere. So I am brand new. This is my first semester here, and I'm really sorry if I say quarter, because I've been teaching at UC Santa Barbara, and they use quarters there, of course. So outside of teaching, I like to do human things, and here are my beautiful moss balls. Hopefully, once I get my first paycheck here, I will be able to afford a cat, and I am very excited for that. So that is that. And thank you in advance for putting up with me. This is going to be a really weird semester, and it'll be my first time teaching here, so there will be things that I am not prepared for, I'm sure, and we'll just have to deal with them as they come up. We will make it work. Alright, so some logistics. Everything, of course, is asynchronous. There is no set time for this class. I'm going to record everything for you, and here's the schedule that I'm going to try and keep. So every Tuesday, around noonish, I'm going to post your first lecture video. I'll try to do it before that, but you never know. This will be my deadline for myself. Your second lecture video, we'll pretend this is like a 2-lecture class. I'll have that up by Thursday, and then any lab introduction video and your lab assignment will be up by Friday at noon. So that's what I will try and do most weeks. You might not have a lab every week, but that is kind of my plan. So yeah, that's that. And because there's no set time, I'll give you a decent window, at least a day, to go and start and take your exams, especially your midterms. So you'll have 24 hours to press the start button, and then once you're started, it'll be like you're in class, and then the timer starts counting for a normal class period amount of time. So hopefully that will work out, and that seems fair. Yeah, that'll be exams, and let us also talk about expectations. So I have been told, I haven't taught it yet, but I've been told that this is the hardest CSCI class here. So keep that in mind. There's going to be some work that you'll have to do. A lot of these concepts, they're pretty difficult. And it's not like you're in the honeymoon phase of programming anymore. Now you know how to do things. Now we have to do them fast. We have to do them better. We have to think about things. Lots of pointers. Sorry about that. It's just a requirement. And because you have already learned how to program and everything isn't beautiful and new anymore, the concepts can be a bit dry, but I will try my best to make them as exciting as possible. Of course, I love this information. I'm weird, and I like teaching it, so hopefully that will rub off on you. And yeah, if you look at the requirements in the syllabus, you have to write at least 1,000 lines of code this semester, and so you can plan for 80 to 100 lines of code that you'll write each week. But I'm not trying to scare you away, of course. I love this information that I'm about to teach to you, and I will be here. I'll have tons of office hours. I'll be here to help you as much as I can. So please keep that in mind and come bother me. Yeah, so the syllabus, if we look through it, I'll go to it in just a second. But you'll have homework that you'll complete on a site called Zybooks, and that will be kind of like reading and some participation activities there. And then also have programming assignments for you called labs, I'll say. And those will be pretty much every week. So that's that, and you'll have 2 midterms. I'm planning for like 2/3 into the semester, or 1/3 into the semester, and 2/3 into the semester. So 2 of those, and I'll definitely have some extra credit for you. Okay, so let me go to the syllabus. Here is the homepage. Hopefully I didn't change it too much by the time you're looking at it. But yeah, let's open the syllabus really quick, and we'll go to what you care about, which is way down here. Okay, so the grade breakdown. So I already said there's going to be 2 midterms and a final. So 10% of your grade is going to be from these zyBooks homeworks, and I'll talk about zyBooks in just a second. And then 35% of your grade will be from labs that you complete on this virtual machine, so please get that installed. And then for attendance, I will give out, because of course you're not in class anymore, I'll give out like weekly check-in surveys that you will complete on Canvas, and 5% of your final grade will be from that. Okie dokie. So that's that. And then 30% of your final grade will be from the 2 midterms, so 15% each, and then 20% will be from the final. And I will weight all those things equally, and yeah, I'll drop your 3 lowest homeworks and your 3 lowest scoring labs. Yeah. Dun dun dun. Late work, I will accept late work up until the end of the semester. I'm just happy that you're doing it, but I am pretty strict with my deadlines. So 1 minute late is late, and though I accept your late stuff, you're going to get dinged pretty hard because of it if you turn something in late, so you're going to get a 50% penalty. So please keep that in mind and try to do things on time. But I will, of course, drop your 3 lowest things. I know this semester is going to be weird for a lot of us. Okay. And then we'll deal with late stuff from zyBooks later, because they're horrible in how they give me their grades. I think that's about it. The final exam, from what I gather, I am allowed to pick like a 24-hour window to give it to you, and we will figure out when that is later. That is not something that I am ready to pick right now. Okay? So that's that. And I think, let us get ourselves... Let me open up this page just very quickly, because we're going to go there in just a second, but we'll go back to the slides now. Speaking of Canvas, I will give you all this stuff. So all these slides, all the annotations that I write on them, all the code that I write in class, you're going to get it. Okay? And yeah, with that code that I write, please go and run it in the virtual machine, this Linux machine that I gave to you. That's where you'll be working on your lab, so please get used to it. And yeah, please watch that video on Canvas. Please watch the video on Canvas to get that working so that you can do your lab. And I will go to this in a second, but this is what it looks like, the beautiful cat background that was default, even though I love cats. It just was meant to be and was already there. If you need a laptop or a better internet connection, the college can help with that, so please see the resources page on Canvas if you're in need of either of those things. All right. And then the class server. So you'll be doing your work on that virtual machine, computer inside a computer. So cool. And then once you're done with the lab, you'll copy it onto the class server. And I have given you terminal commands that do that for you. So you shouldn't really have to touch the server too much on your own. But I made you all accounts, and make sure to change your password. So in one of these videos, I will tell you how to do that if you haven't seen it already. Okay? And so now onto our textbook. The textbook is virtual, so you have to buy it. It's from this website called zyBooks, and I will assign you homework out of it to complete. So it's really nice because it's interactive, and it's really going to help you learn the material, I think. So please take advantage of that, and you can see all the assignments when they're due and things like that on here. Actually, I think it won't be inverted for you, but it'll look like this. And yeah, that's what a chapter looks like. A little section. You have little activities to make sure that you're learning things, which is super nice. So that is zyBooks. Please get that. Yeah. Read ahead if you'd like. In the worst case, I will extend the deadlines of assignments, so you won't really get any penalty for reading ahead. It'll only help you. And then finally, Piazza. So instead of email, please use this thing called Piazza. It's on the left-hand side. It's also on the home page, right there. So either one, go to this. It is a question and answer service. It is great. It is replacing emails to me because my inbox is disgusting. So this is really nice. You can post questions to either the entire class, which means your peers can help you too, or you can post them to just me, okay? And so this should replace email for pretty much every case, I would assume. And yeah, I think it's really nice because your peers can help you if you post a public question, and you guys can come at the answer together. And then I can also pop in and help. So please try to ask all of your questions on Piazza, and it should work out pretty well. One nice thing is that you can post anonymous questions publicly. So if you're kind of scared of having people see your name, it's still better to ask a public question, but you can just get rid of your name in that case. Okay, so think about that, consider it, and yeah, try to ask a public question as often as you can, but there are times when that is not a good idea, so just use your judgment, like when you're asking a question about the midterm, or like you're trying to share a whole bunch of code that has your answers in it. So try to keep that stuff private when you're asking those questions. So that's for non-office hours kinds of interaction with me and the rest of your peers. And then we have office hours. So those are going to be virtual on Zoom. You can make an appointment, and right now here's the schedule that I have made for myself. So I will always be here during the times that you see on this page. I might have meetings and have to like change these around a little bit, but this is what I would like at the moment. So hopefully they get to stay like that. And you'll just click my Zoom link and you'll see my face and I can help you. So please come to these. I yearn for human interaction. This is a horrible quarter and I don't like talking to myself, but this is how it has to happen. Okay. Yeah, so please come to office hours. And with that, let's get in to non-logistical things. So why are you here? What are you about to learn? You are about to learn algorithm analysis and data structures. I'm glad you asked. So the idea is we care about how fast things run now. In CSCI 40, we were just happy with you solving a problem and getting it correct. But now we want to think about our options because there are a bunch of different ways to implement a program. Only some of those are the fastest options you have. So we want you to think about that now. And then also that's going to come, ways to solve problems come down to how you manage your data. Right? And there are fancy data structures that you will learn about in this class that perform certain operations super quickly, and there are a few standard ones that you're going to learn. So we will learn to manage our data very, very quickly, I guess would be this class's catchphrase in one sentence. But first we're going to go through C++ some more. So you know about classes. That's about as much information as I require from you so far, but we're going to take a deep dive into what classes really give us and talk about object-oriented programming quite a bit at the very beginning. But before any of that, I've made this review video that I want you to go and watch if you feel like it. This is completely optional. You don't have to watch it. It's not part of the lecture. It's just extra. It's about 40 minutes, though. Maybe you can skip around to the things that from this list that you feel like a little shaky on. But please watch that if you would like. So skip it if you don't want to watch it. Yeah, so that's that. And before we take a deep dive into maybe not as cool things, let me show you some cool things, one of which, one program you will be helping to write this semester. All right? Because all this stuff is happening on the terminal, and maybe you hate the terminal. Maybe you think it's super boring. But I disagree. It's all about your point of view. What's this called? Rotating cube. You can do graphics on the terminal, if you didn't know. What? And here's a 3D rotating cube. It's really drawing it in 3D, I promise. I programmed it. So you can actually do fun things on the terminal if you try hard. So that's that. That's my coolest example, but here's one that you will be helping to implement. If you remember, if you've ever seen this snake game, it's from the old days, but you have this little snake. It moves, it eats food. Whee! And it grows. And that growing bit is modeled by something called a linked list. It's a data structure that you will be learning in this class and implementing yourself, which means that you will have a hand in making this program work. So I've made this game for you, and it's your present after you make the linked list data structure work correctly. If that works correctly, then this game works correctly. All right, so you'll get this code in due time. And then finally, here's where I'm going to work for today. So I hope I have motivated you, or at least convinced you that the terminal can be fun. So now, please look at the review if you need that. Otherwise, we would have ended here. And let's talk about object-oriented programming, or OOP. And I just want to warn you, I'm about to throw a lot of things at you right now. But remember, one of the nice things about this semester is you can pause, you can go back, you can watch it all over again. I'm going to give you all this code, so I want you to try it out. So don't feel overwhelmed, because you can control my speed. All right? But there's a long list of things that I need to get across in this class, and we have to start today. Okay? So here are my goals, here are my outcomes. They're more for me than for you, but feel free to look at them. And let's get started with these things. So, namespaces. You've used this word already in C++. You've said stuff like using namespace standard. Maybe that's all you've used. All the namespace is, it's just a way to keep separate things. If you use something, if you have the same name for two things, a namespace lets you have both at the same time. If you were to put both of these f functions just out into a C++ file, the compiler would of course complain. It's like, I already have an f, thank you very much. No, you can't have two. But namespaces allow you to do this kind of logical splitting of things. So you can have your foo namespace, and that has an f function, and then you can have your bar namespace, and that also has an f function. So I won't really have you use namespaces all that much in this class, but now you know how to make them yourself. And technically, when you write classes, every class has its own little namespace, so technically you're always using them. So if you wanted to call foo's f, you'd just say foo : f, and if you wanted to call bar's f, you'd say bar : f. Okay, and that's also a nice thing. If you ever decide to write your own version of the standard library, you can just make your own cout in the global namespace, and then you can always get a cout from the standard library with that standard : and you already know all of this, of course. You know how to use the using keyword, and that makes it so that, all right, I plan to use everything in the standard library. I don't want to write these colons all the time. I'll use my using keyword for that. So I guess, if anything, think of those double colons as like equivalent to an apostrophe s. It's like foo's f, bar's f, your class's f. Okay? So that's namespaces. I don't want to dwell too much on that. But implementation and header files. If you have not seen these before, I'm going to introduce them now, and they are very, very useful. So the idea is your programs are getting large, and we need to split them up. All right, so we're going to put them into what's known as implementation files, which have the prefix or suffix CPP or CC, maybe you've seen before. I prefer CPP, so that's what I'm going to use. And those have like the implementation, your function bodies and things. And then you have header files, which have the declaration, so just enough for the compiler to know how this function should be called, which types are involved. So header files contain declarations, and so you'll have like function declarations and class declarations there, but you'll implement them in a corresponding .cpp file. And then once you get into headers, we have weird concepts like infinite inclusion of them, and I will give you examples of these things. So let us make the world's most complicated program. It will revolve around this add1 function. All right, so I'm going to go to my terminal, and here I am in the code from class folder that I've made for myself, and I will make it larger. How's that? So now I'm going to go into the CSCI 41 folder, which has the review right now, but I will make a new folder for today. Make dir lecture 01 and go on into that. Okay, so here I am. It's an empty folder. Let's put something in it. So I'm going to edit a file called add1.cpp, and that'll be that. So here I am. I guess I will get started with that add1 function. So what is it but a function that adds 1 to things? So int add1 takes an x, and it returns an integer that is 1 more than that x. Okay, very nice, very nice. And we can use this in the main function. We can be like, cout add1 42, the best number in the world, return 0. And then, of course, I need to include IOStream. And because I didn't use the colons, I have to say using namespace stood. And one nice thing is it's customary to have the main function come first and write all your other functions second. And if you want to do that, well, then you have to put a declaration so that main knows just enough about how your function is called and the compiler won't complain. So that is a complete program, add1 function, and so this should print out the line 43. Super complicated, I know. But the idea is now, this is a super long file, so we need to split it up. Okay, so actually, I'm going to make a directory for this, because we're going to do this a few times. So make dir add1 library. That will be where all of the files from this example go. So I'm going to put this file into it, into the add1 library, please. And I'll go inside of that folder now. Okay, so what we're going to do is we're going to split up add1 into a header file, which contains the declaration, an implementation file that contains the implementation, and then also a separate one because the main function is kind of also separate. All right, so let's do that. So vim add1.cpp. Dun dun dun. So the first thing we want to do is get the main function out of here. It's not part of the add1 library. It uses it. All right, so let's make a new file called main.cpp. Let's do that. And then we'll put the main function there. All right, we'll delete it, put it there. And I guess it's going to need IOStream and namespace standard, so we'll put that over there. There we go. And it'll use this function that we put somewhere else. So now we have an add1.cpp, which contains both the declaration and the implementation of add1. Now we're going to split that up into a header file and an implementation file. So let's make our add1 header file, and it'll have the same name, add1.h. Remove the declaration, put it there, and so now I have a very nice little library for myself. I have the add1.h file, which has only the declarations. This is called a header file. So this is a header file, and it contains the declarations of things. Okay, and then I have my .cpp file, which has the implementations of things. Oops. And then finally I have my main file, which actually has the main function. And uses our add1 library. Okay. So how do we compile this program? Right now, don't worry about the infinite inclusion. Let's go here for a second. So I'm going to compile this with the following. G++ standard equals C++ 17, my files, and then -o and my output file. Now let's see why that is. Well, first of all, if I want to use this add1, I have to include the library. Include add1.h. So you include header files. That's all that the compiler needs to know to call the function. It just needs to know the types involved, and that's what the add1.h file does. When you include something, if you didn't know, saying include add1.h, it actually just copies and pastes that entire file into this file. Which is weird enough, but that's what it does. So that's how it knows now. It now has the declaration for add1 because it just included this entire file, which has that declaration. Okay? And then now we have the implementation. It's customary to also include your header file, and that will become apparent when we write classes. Okay, and now we want to compile this. All right? So in order to compile and run this program, we say the following. So it's very possible that you had like a compile terminal command from CSCI 40. Now we're going straight to the source. We are using the GNU C++ compiler. This is the real command for the compiler. And we're giving it the C++ 17 standard, so from 2017, the cool newest version of the language. And then you give it all the files that you want to compile. And then you give it -o if you don't want that a.out thing. And then you give it the name of the output that you want. So in order to compile this, we're going to say g++ standard equals C++ 17, and then main.cpp -o main. And this is incorrect right now, so don't trust me just yet. Let's take this. And I am going to go and try to compile this now. So I'm going to make a new window for you just to keep it all nice and logical. And what I'll do is I will try to do that thing. I'll try to go and compile. And it'll get almost all of the way. It includes, it copies and pastes the add1.h file, so it knows how to call this function, but it will give me an error in the linker stage. That's what LD stands for. It's the linker. It's trying to bring together all the libraries, and it's saying, well, I know how to call add1, but you never gave me the implementation. So that's what we need to do. We need to also give the implementation file right here, but never the .h file, because that's getting copied and pasted. And then finally, does it work? And we can say /main, and we run our program, 43. So that compiler call made that main file for us, and we can run it with 43, and get 43. Okay, so also include the implementation file, and you're golden. All right, so that's what's working there. And the reason you don't have to give implementation files again is because that include copies and pastes the current file. And so what we've done is we found a logical separation for add1.cpp, which contained the add1 implementation. Makes sense to put that alone. And then we made an add1.h which had the declaration for the add1 function. Decal, I'll say. And then finally, as the pièce de résistance, we brought it all together in our main.cpp file with our main function. And we included our library, and we called our function. All right, so this is how you separate things in a nice, logical way. Okay, that is the idea. Now, the last thing that I promised you is, what in the world is this if and def blah blah blah? Well, let me show you one problem. This is going to be very contrived, but it actually happens. So let me do something really stupid. Inside of add1.h, I'm going to include, you guessed it, add1.h. So this is going to try and copy and paste this file into itself. Now, let me try and compile this. You know what's about to happen. It's going to try and keep on copying and pasting this, because it'll copy and paste this, see that it needs to include add1.h again, copy and paste it again. And so you're just going to have a bunch of these lines all over again, forever and ever. And you can see what's happening. So the way that you avoid this, and trust me, it does happen in practice. It's not as obvious when it does happen. You never actually include your own file, but with enough indirection, it does happen. You say if ndef, so if not defined, and it's customary to use the name of the file, add 1 underscore h. You can't use dots because this is like a variable name. Define, add 1 h. At the very end of the file, you say end if. So this is one of those rare cases where I'm going to ask you to memorize something, just in case this doesn't make sense. But what we're doing, any line starting with a number sign is a preprocessor directive is the name. And these things, you notice they don't have semicolons. They get run before the compiler. So it's like before the compiler is run, it does all of the things with the number signs. And one of these things that it does is define variables. So we're defining a compiler level variable right now. And we're doing it only if add 1, this variable does not already exist. We're not giving it a value. We don't have to. We're just saying that this variable exists. It's a compiler level variable, if that makes any sense at all. And so only if it doesn't exist will we do everything inside of this little compiler level if statement and actually include the rest of this file. So now I can include myself all day long. And it doesn't care because it'll only ever include it once. It makes sure that this is only ever included once. And so you want to do that to ensure that this happens. You want to always put this with your header files. Okay. There we go. I think that is everything that I wanted to talk about. Okay. So that is that. And with that, let's move on to structs. Let me see how we're doing. Okay. So we're going to try and create classes ourselves. We're going to invent it. So let's write a program that keeps track of some information as a user enters it. So we'll keep track of the count, the number of times that the user has given us information. And then we'll also keep track of the current maximum out of all the values. So we're just getting a bunch of ints from the user. You can pretend this is like from a pacemaker. It's keeping track of your heart rate and keeping track of any times where your heart rate went really, really quickly, because then it has to do something. So we're going to save the max because that matters to us. Okay, and then again we're going to compile like this. So let us make this file. Let's go back out here. Do I want to say, no, I'll just say it in this current directory. So vim stats.cpp. So again, include iostream using namespace std int main, always return 0. And so what we're going to do is we're going to ask the user for some stuff. And always keep track of how many were entered. And we'll also keep track of the maximum. Alright, so we're going to have, I think it would be a good idea to keep all of them together. So it's not really necessary, but we'll use a vector. So I just want to show that. So we'll make a vector of ints called current nums, and we'll actually start it out with already something inside of it, just one thing, and this will make what I do later make more sense. Then we'll keep track of the count so far, and then we'll keep track of current max. And we know that it has to be 42 right now, so I'm just going to say 42. Okay, that's the idea. So now we're going to ask the user to implement, or to add stuff, please. So how will we do that? We will, I guess, say cout, enter the next number, and we'll get it. Just like that. And then perhaps we will say, while the number is not equal to -1, because that will be our stopping condition. So when the user enters -1, then we're done. We will then do stuff. We'll add it to our current nums, add 1 to count, and then recheck current max. Okay. So current nums, we can say dot push back the num that was just entered, add 1 to count, recheck the current max. Let's see here. And we're going to do this in a slow way. So let's say current max equals get max. Current nums. All right, we'll write a function that does that. Then we'll ask for another number. So we'll just keep doing this till the user enters -1. All right. Make it all pretty. And now we need that get max function. So it returns an int. It takes a vector of ints, and we want to be all cool and take a constant vector and a reference to it so that we save memory so it doesn't get copied all over. We're just giving it straight to get max, a reference, and we don't want to touch that thing, so we give it const as well. All right, now we got to go through it. And let's assume that it always has one thing in it, so we can use the normal max algorithm. And hey, I made sure it always has one thing. All right, so then we say, we start out with looking at the first index, and then we just go through the rest. For int I equals 0, I is less than b.size, I plus plus. And technically we already looked at the first index, so we can start at the second index. Remember that indices start at 0, so it's weird when I say that and write 1. Now we'll see if the thing that we're looking at, v.i, is greater than our current max. Well, then we need to update our current max. So we'll say max equals v.i. And finally we'll return the max that we found, because that's the max for the whole thing. Okay, I think that does it. And so now I can, in theory, compile this. G++ standard equals C++ 17. This is called stats.cpp-o stats. Next number, well, we already had 42, 43, 44, 45. The one thing that I forgot to do was actually print out the new max. And then maybe we should also print out the entire array of things, so numbers so far. Let's actually just put it on the same line. So let's go and print out all the numbers. We'll just print them all on the same line, maybe. We'll say cout current nums.at_i, and then a space in between them all. And then finally, once we're done printing those out, we'll print out a new line. All right, so how does this look? 43, 45, I guess. 0, 2, 3, 4, 5. Did I do something wrong? I guess I did. It's just getting a bunch of 45s. I wonder why. Pushback num. Oh, I'm so sorry. I made a new version of the num. I shouldn't have done that. It was local to the while loop. This is why we do this live, so you can see my mistakes and you don't feel bad about yourself. 45, that's a new max. 3 is a new one, it's not the max though. 46. Yeah, this looks like it's doing well. 0, -1. Alright, we have a program that's working. Cool. Alright, that's the first step. We've got all that stuff. And all that stuff, well, wouldn't it be nice if we can put it all together? So, let's do that. Let's put it in one place and use this thing called a struct, which is sometimes called a plain old data structure, because it just holds a bunch of things, a bunch of different types at the same time. It's usually how you use it. So, up here at the top, I'm going to put all my data together in a struct. We'll call it stats. Ends like that, and inside of it we'll store the vector. So, pretty much all this stuff. With those names. So now they all live together. Count, current nums, current max. They all work. And instead of making them all separately now, I'll make them in one fell swoop with saying stats s. It's a brand new type that holds all those things. And now we have to say, well, the vector inside of s is called current nums. Let's initialize that. s.count equals 0. s.current max equals 42. And so now I just have to put s dots all over the place. Don't mind me as I do that. Are you happy? We'll find out. That's pretty simple. So we put everything together now in one nice place. Okay, and it still works just fine. So that's what structs by you. They allow you to put stuff together, which is really nice. Well, we can do better. Let's make classes instead. All right. So again, it'd be nice if we had that struct. We had all our data together, but the operations were still outside, like this initialization, this get max function. No. This is only relevant to our stats data structure. Let's fix this. All right, so I'll make a class now. We'll convert our struct to a class, and we'll call it the statistician, or just statistician for short. All right, so now we'll have operations on our statistician. So add number, max, and we'll also need an init function to get it to get all that stuff started. Okay, so I'm going to keep everything public for now. I think you know where I'm going. We're trying to invent classes, right? So no more struct. Bye-bye. I'm going to say class stats. And we're going to say, yes, it has all these things, and they're public. And we'll have some functions, some operations defined in this. So we're going to have init. We're going to have get max. We're going to have, we'll make an add function as well. So void add. Did I say add number? Ooh. Did not mean to do that. Yeah, add number. Okay. So now this get max function belongs to stats. And then also I said it was going to be called statistician. So there's that. No. Where was I? Yeah, that works. It's your get max function. And we also have statistician's init function, which, after the statistician is made, we'll call the init function to do all of this stuff. So stat is titian, s, and we'll call s.init to fill it with stuff that we were doing before outside of it. And so now it's no longer s dot because it belongs to the current object. Current nums, count, current max. Yeah? And let's see. Get max no longer needs the vector because we know the vector. Its name is current nums. It lives inside the class, right? You see that? Now, this v needs to go away. It needs to be replaced with and we will replace that with how do I want to do this? We'll replace it with current nums. That's how I'll do it. And that will solve that issue. And then finally, instead of saying push back as a user of our class, we will say, we'll abstract away that information and have an add number function that adds to the statistician. And it adds a new number n. And I need to give it that, don't I? Alright, and so what this will do is just add that one thing. So current nums dot pushback n. And so everywhere I used all these things, I will change them. S dot, I want to say s dot add number now instead of s dot current nums dot pushback. Right. And then I want to say, yeah, I still want to iterate through that thing. S dot current max equals get max. Well, we can say just get max, right? In fact, we don't have a current max variable. Oh yes, we do. I'm so sorry. Well, let's set that to s dot get max. That makes more sense. And we don't have to pass along anything. It knows where the vector is. There we go. And then we can say all these things, current max, print it out. And yeah, that's that. So now our class is working a little bit. 43, 44, 0, -1. It does everything. Everything under the sun. It's all public though. So before I get to the next slide, let's do our favorite thing. Separate it all out. So we'll have a statistician library. I'll keep it stats for short in the file names at least. Alright, so move that into here. Go inside. Oops, sorry. Oops. I sure did that wrong. Let me fix my mistake. There we go. It's like nothing ever happened. Alright, we have our file again. So, now we're going to make stats.h and put the declarations of things. Right there. Or actually, it needs to be removed from the implementation file. Alright, there we go. And then remember, this is a header file, so if ndef stats h, we don't want to infinitely include ourselves. Define stats h and if. And we use vectors, so we got to include that. And one big thing, one no-no, is never use namespace stood in a header file. Okay? So we have to say standard vector when we do it like this. And the reason for that is when we go and we include stats.h, remember it's getting copied and pasted. So if we include it in a file that wasn't already including namespace standard because it didn't want to, we just forced our views on somebody else. We cannot do that in a header file because it's getting copied, okay? And to places we do not control. The user is using our library, and we want to minimally affect the user's program. Okay, we just want to add our stuff, nothing new. And so this is the implementation file. What we will do then is finally move the main function. Main.cpp gets that. Include iostream. Honestly, it's going to include everything that stats.cpp included. So let's go there. Go there. That should, in theory, do it. And remember now how you compile this. Let's make sure that all this stuff has been saved. There we go. We say G++. Well, I'm in the wrong folder now. It's inside of the stats library. G++. Standard equals C++17. We say stats.cpp. And we also say main.cpp because we need to include the stats library implementation. But the header files are getting copied and pasted. And then again, like clockwork, everything works the same. We just separated our things in a logical way. All right, so now, this is called getMax. How fast are these member functions, relatively? Well, our init function does a few things. It sets the current max, the count, the current nums. It's 3 assignment statements. So you can imagine that it's going into memory, affecting 3 things, and it's done. Should be pretty fast, right? Our computers can access memory quite quickly. All right, add number. Well, that's just going into the vector and adding a new thing. It shouldn't take that long to add one thing to a vector. We'll learn exactly how long it takes quite soon. But this just adds one thing to a vector. And there are some interesting things to note. Technically, the vector might be of size 1,000, and we're adding the 1,001st thing. Maybe it's of size 1,000,000, and we're adding the 1,000,001st thing. That actually changes how long it takes to add a thing to a vector. But we won't talk about that right now. Let's just assume it's very quick, and it always is just instantaneous to add something to a vector. And that'll actually be the correct intuition anyway. And then finally, getMax. If we look at that, well, this is the one that's kind of interesting. Well, this has to iterate through our current vector. That vector could be long. If it's long, it's as if you had done that body, you've executed the body of this function, this if statement, 1,000,000 times if it's size 1,000,000. So it kind of depends on the length of the vector, how fast this getMax function is. You see that? And so whereas init and add number, they were kind of in a class together, like they're both nice and beautiful and pretty fast. There's like this logical split that I think you see where getMax is not the same. It must take more time in a sense, especially if the vector is long, and that's what we really care about when we're programming. So relatively, these are kind of in a class on their own, or together, and this one's in a class of its own, because it's a bit slower. And I hope you see that. I hope there's some intuition in your mind as to why that's true. And we'll make this precise later. All right? So with that, let's see how we're doing. All right. Public and private. Well, our current class has one main issue in that I can do this in the main file. Boop, boop. And I think I'm already doing it. I'm setting the count. I'm setting the current max. No. I could just as easily do something like this. -5. It's something weird. No. We cannot do this. We cannot let our user touch our stuff. No thank you. So this can actually be moved nice enough to the add number function and say count plus plus. That's nice. That takes care of that. But still, again, we have the issue of we're setting the current max. What? No. We can't let that happen. Maybe we can just call the getMax function instead. But if we wanted to still keep that variable around, we'd have to like set it. We could set it up here maybe. We could say that current max equals max, and then again we solve the problem. But again we have another. We're going through current nums, and this is just all horrible. We never want our user to even try this stuff. And so the standard way of doing that is to section off. These member variables, they are private. They do not get to be touched by the user. And we will give an error if they do get touched. So right now, I'm using the dot on a member variable. I will get a compiler error because I added private. And that's what we want to see. Ah, yes. We don't like it. Doesn't like it. We don't like it either. All right? Because we know what's best for our class, not somebody else. No. We need to have control. So one thing that we can do, if we want to use these current nums, we can add a getter, which gets that thing for us, for the user to use, in a safe way. And maybe we won't let the user touch the current nums, but we'll give it to them. So we'll say standard vector int. I'll give them it as a reference, but also a const reference. Okay. We'll say get current nums. And I won't go through the trouble of putting this in the implementation file. I'll just put it right here. Return current nums. This is nice because it makes sure that the user only ever gets the current nums in a non-modifiable way. I'm using const. See the review if you need help remembering what const means. So now I can say, instead of current nums, I can say get current nums, just like that. Okay. Now it'll all still work. And we're also controlling access, which is exactly what we wanted. And this should compile. It should run. And now you don't have to trust your user not doing stupid things. You're just guaranteed that they're not going to do stupid things with your member variables. And then finally, friends. So sometimes it's useful to give a function that lives outside of the class access to your private member variables. If I wanted to make an add one to every single number in our current nums vector function, and I wanted that function to live outside of the class, I have to do a special thing. I have to make it a friend of the class, which is the cutest little metaphor. But here's how you do it. So I'll say, we're going to make an add one function to nums. That's how it's called. And so it'll take the statistician, have it take it by reference, and it'll add one to everything there. So let's go and implement it right now. Boop, boop, boop. It'll just go through this entire vector, and I'll copy that. It will add one to everything. So current nums dot at I plus equals 1, we'll say. And this is not going to work because it's not talking about s yet. It's outside the class. We need to pass it s, our statistician, that we want it to work on. And then also, it's still private, so it cannot see it unless we say we trust this function. And we have to say it inside the class. It's our friend, which is so cute. And so you say, with the declaration, you say friend. Okay, that's what you do. Then you can declare it out here and define it where you need to define it. And now we can use it. Maybe before we print out everything, we can add one to everything. Alright, and so this is a function that exists outside of the class, but it's a friend, and we gave it access to our private member variables. Maybe I should put that somewhere. Alright. And so that's the beauty of friendship. The power of friendship, if you will. And so you can see every time I add something, the max is always changing because it's putting new stuff in it. Alright? Oh, and I forgot to apparently start at 1. How dare I? Now it should work just fine, as we intended. Okay, so that's the idea. I think that's kind of cool. And now, in like the last 15 minutes of class, let's get into testing. Because I'm going to force you to test what you implement in your lab this week. So, how in the world do we trust our implementation? How do we know that what we wrote is correct? Because you should never trust yourself, no matter how many years of experience you have. I don't. I never will. One thing that you can do to gain confidence in your implementation is to make a bunch of test cases, okay? They help to convince you that things are right. You, of course, can't run your program on every possible input always. Just think of trying to run it on every single integer, every single vector under the sun. It's impossible. You can't enumerate all of them. So you can get close to believing that you're okay, though. That's the idea. So a test, it takes a given piece of code that you're worried about, and it goes and tests it with a predefined input that you define. All right, so you specify what you want it to run on, what your function you're testing, for example, is going to run on, and then you check, because you know what the output should be, because you gave the input, whether or not the output is correct. Okay? So for example, we know that the following code, we should be able to check, if we want to trust our init function, that it results in the following. It results in the current nums, or s.currentNums.at 0 equals 42. We made sure of it. So that's something that we could check in a test case. That's the idea. So for example, now let's test our max function. And here's my test case. Here is enough for me to believe that our getMax function is doing the right thing. So we'll make a new statistician. Let me make some bullets here. We'll call init on it. And then we know immediately that getMax should right now return 42, because that's what init did. Yeah? And then let's add something. Add 43 to our statistician. All right, let's call it S. All right, so add 43 to S. Then what should happen if we call getMax function now? Should return 43 now. And now you see the game that I'm playing. What are all the ways that getMax could go wrong? Well, maybe it could just stop there. So let's add like 44. Make sure it keeps on changing. And then once you get enough experience, you'll look for these edge cases. But right now, this test, it will pass if I implement getMax as, well, whatever the last thing is in the vector, return that. Okay? So we need to be a bit smarter. So what if we add 0 now? Add 0 to S. Then getMax should still return 44. Okay? You see what's happening? I hope that makes sense. And so if our getMax function, after all of this, is doing everything correctly, then I would have confidence that it's doing the whole thing correctly, that it's implemented its function properly. And that's what testing is. So let's make a test. Maybe I'll make a new file, actually, called test teststats.cpp. And I'll have it, instead of main.cpp, I'll have it make its own little test cases and run it there. Have a different main function, so I'll compile it in a different way. Alright, so the common thing to do is to make a function that tests one test. Alright, that runs one test. So we'll make a test max function. I'll put it right here. And what it'll do is it'll test the max function of a statistician class, of a statistician object. And it's common to do these small kinds of tests for just one function at a time. This is called a unit test. It tests one small bit of our program. And so the idea is you're going to write a bunch of little unit tests, and together they are mighty, and you get the final bigger answer, and you can believe that your final bigger class is all correct if you make enough little test cases. That's the idea. So now if I run my test max function, I'll do everything that I plan to do. So I'll say statistician s.init. Now I'll test if s.getMax. Well, it better be 42 right now. So if it's not 42, then we'll see out we have a problem. And then we'll keep going like this. So then we'll add 43. And if the max isn't 43 now, oh no, sorry. If the max isn't 43 now, we'll say something's wrong. Do the same one more time for 44. And then finally, we'll try and add 0. And the max shouldn't have changed. All right, so if we get 0 output from this program, if it says nothing to us, that means that none of our tests failed. All right, so I'm going to compile it like this. Instead of main.cpp, I'll give teststats.cpp. Oh, I overwrote main, sorry. We'll call it teststats instead. And hey, we get no output, so it means that it might be correct. So let me just briefly mess up statistician. Oops. Now, if we look at our test, it's going to do some stuff, and that stuff is going to be wrong. At least once. Well, at least 3 times it's going to be wrong, because it's always going to take the first thing, or the 1th thing, I guess, to be the max, and that is not always the case. Okay? So that is the idea, and yeah, I think that is what I wanted to say with that. Let's, of course, correct it again so that you have a correct program to look at and study. But that's where I wanted to go with that, and I think that's where I will leave you. So notice how far we came. We first made this little statistician, or the stats struct that combined all this information. So we made our struct called stats. And inside of it, it held our count, our current max, I think it was current nums too, right? And so it just held this kind of data, these different types all together. And that was nice because it gave us a nice little package that we could pass around to places. Okay? And then finally, we discovered that classes can help us here because it can take what we had before. Now we have statistician. It had everything that we had before. When we make a statistician in memory, it gives us those member variables like count, current max, and current nums. And then it also gives us the cool new thing, of course, which will be rainbow. These functions, init. It works on the class itself. Init, getMax, add number, or whatever I called them if that wasn't the name. Now we have operations in addition to data. Data ops. Yeah? And then we looked at how fast our things could go. That's important. And then we restricted our data. So now not everybody gets to access count, only the implementer of the class gets to access count, current max, current nums. And we can give access as we wanted to. We added a getter, of course. And if there's anything that you need to give outside of your class access to the private member variables, you can make it a friend, which is so cute. And yeah, then we tested our class. So with that, this is where I will stop, and I will see you in the next lecture.